The slope of a secant line. This is algebra. The average rate of change, also algebra. The difference quotient, also algebra. Limits. This is something we studied in this class. And the squeeze theorem. Asymptotes, vertical and horizontal. We did not talk about slant yet. Continuity, when a function is continuous, and continuity at the point. When a function is differentiable. Remember, it has to be continuous and cannot have vertical tangent, cusp, or corner. The epsilon delta definition of a limit is pretty much done. So you're not going to see this again. The intermediate value theorem, very important theorem. How to find f prime of x with a definition. One definition, and this one has two. And the measurement unit for the rate of change. Always remember, it consists of two measurement units. One coming from y value, or y from the function, and the other one from the independent variable. Okay, so do you have any questions for me? I'd like to start with your questions. Anything you want to ask? If not, we'll start chapter 3. Any questions, anyone? Anyone? Okay, in that case, we're going to talk about differentiation. I know everyone is anxious to get to this. Differentiation. Differentiation rules. Okay, we will start with the simplest one, which is the power rule. When we differentiate x, so this is plain x, not a function. Well, x is a function, but not a function composition. To the nth power. And we differentiate this. This is our first rule. Anyone remembers this rule? It's okay if you don't. Anyone would like to tell us what x to the n? So remember, this is my n and this is my m. 3 bubbles, 2 bubbles. It doesn't matter. You can use m or n. It's not important. Anyone knows this rule? It's okay if you don't. So the power rule says that if this is just plain x, if it's not plain x, we have a different rule. But if it's just plain x, we bring down n, the power, and we subtract, we copy the base, and we subtract 1 from the power. This is the power rule for plain x. So if I'm asked to find the derivative of x to the 7th, I will bring down 7 and subtract 1 from the power. Now, if I have a constant that I want to differentiate alone, the constant does not have a rate of change, which means the derivative of a constant is 0. But if I have a product like 3x to the 4th, and I want to differentiate this, the constant stays in front. Remember, we had this before. We determined the limit of 3 times a function as x approaches 4. We can take the 3 outside because it's a factor. So we can write 3 limit of f as x approaches 4. The same thing here. So 3 is out because it's a factor. So we bring down 4, but we have to multiply by 3. So the answer will be 12, x to the 3rd. So in other words, when we differentiate a constant times a function, we keep the constant outside and we simply differentiate the function. Okay, before we look at different applications from the book, we want to talk about this function. If if you remember, this is the exponential function. Basically, is the natural exponential function because the base is e. It turns out that this is a very friendly function because when we want to differentiate it, we're going to get e to the x. So the function, very interesting, the function, its derivative. Or the derivative of this is the function itself. So now I would like to practice these rules. So I'm going to share my screen. And let's take a look at a few applications. I'm sharing my screen right now. And we go to 3.1. As you see, the power and new derivatives from old, I'll explain in a minute, and constant functions, so exercises. Okay, so let's select anything between 3 and 34. I'll go slowly and you choose.
Eight.
Which one? 8? 8. Very good. So let's start with 8. So 8, we have f of t equals t to the third plus e to the third. Awesome. So what does the concept of the derivatives from old? Well, this is a function. This is a sum. So if I have a function like with the limits, if I have a sum of two functions and I need to differentiate, all I have to do is differentiate the first function plus differentiate the second function. We did the same thing with limits. And the derivative is a limit, right? Same thing. If this is minus, then this will be minus. So we have a couple of rules already. The power rule, a constant prime is 0. A constant times a function prime is the constant times f prime, like similar here. When we have a sum or a difference to differentiate, it's the sum or difference of the derivatives. And whenever we look at the natural exponential, pure. Because if I say something like e to tangent x, this is not pure. This is a combination of a natural exponential function with tangent. But when we talk about pure, the simplest possible natural exponential function, and we differentiate that, then we have e to the x. We are going to learn how to differentiate this later in this chapter. So don't bother with it right now. We're not using this rule. We're using something else. You'll see. Okay, so then when we differentiate f, then we get f prime of t. This is the power rule. We bring down 3 and subtract 1 from the power. But this, e to the third, is a constant. What did we say about a constant prime? How much is a constant prime?
Constant prime.
How much?
0.
0. So this is it. This is the derivative of f of t. Again, what does this give? It gives the instantaneous rate of change of this function at any point where this function is differentiable. Well, it's a polynomial function. It will be differentiable everywhere. No problem. So if this is a profit function and our boss says, well, tell me how fast is my profit changing, you will have to determine the derivative and then tell him at a particular instant, today, tomorrow, last month, next month, and say, ma'am, sir, the profit of the company is changing at this rate on such and such day. You have to plug in the time or whatever it is, the independent variable. So that's the meaning of this. Perfect. Good. Next, what else would we like to choose from here? Actually, I would like to choose 12 and 13. Are you okay with that? So 12 is v of t equals t to negative 3/5, and then plus x to negative 3. I managed to copy from two functions. I always do that. So 12, t to negative 3/5 plus t to the 4th. I do that a lot. It's not that I can't see, it's just that my computer is so far away. Okay, so that's my 12, and I think I fixed it. And the other one, s of t, very good, is 1 over t plus 1 over t squared. Awesome. Okay, so let's start with number 12. So we want to determine v prime of t. Can anyone tell us how to write this? Or what is the starting point? Step by step, what do I have to write? If this is not...
to the power of 3/5 minus 1.
Yes, but I have to bring negative 3/5 in front.
Yes.
And subtract from negative 3/5, subtract 1, which will be negative 8 over 5. Perfect. And now, when I differentiate t to the 4th, what do I get?
4t.
Yes, so positive 4t to the 3rd. This is it. So we bring down negative 3/5, and we subtract 1 from negative 3/5, negative 5 minus 3, negative 8 over 5, or negative 8/5, plus 4t to the 3rd. Awesome. Now this is a very important function, because we need to remember to rewrite it. How do I rewrite this? We're going to do this piece only once. I'll come back to this. So let's talk about 1 over t first, because we have to add this to the long list of formulas and rules. So 1 over t has to be replaced by t to negative 1. This is one time. From moving forward, we are going to know the formula. So then when I differentiate t to negative 1, I use the power rule. Same power rule. Bring down negative 1 and subtract 1 from the power. And this turns out to be negative 1 over t squared. In short, we have to remember moving forward, then 1 over t prime is negative 1 over t squared. So please add it to the long list of rules. What long list of rules? Okay. The power rule for plain x, the constant prime, constant times a function, e to the x, sum or difference, and now we have this. We are going to add one more. I know I didn't forget about the problem. I'm going back to it. This is another one that we have to remember. This is t to 1/2. And when I differentiate t to 1/2, I bring down 1/2 and subtract 1 from 1/2, which is negative 1/2. We don't like to write it like this. We will write it like this. So moving forward, we have to remember this rule. So we never have to look it up. The square root of t prime, or x, it doesn't matter, is 1 over 2 the square root of t. This is very important, because if we need to look up these very simple rules, then we are not going to be able to get where we are going. Okay, so now back to the problem. When we differentiate, so yes, we already know this. I'm going to leave it alone. But this one has to be changed into what? How do I change this? Into something that I can easily differentiate. 1 over t squared becomes Anyone, please? 1 over t squared will be replaced by,
Is it negative 1 over t to the 4th?
no, this one. I have to replace it first.
Mm.
In the same way we did 1 over t. In the same way I have to change 1 over t squared into t to which power? We cannot differentiate like this. Say it again.
To 1/4?
So if 1 over t is t to negative 1, what will 1 over t squared be?
Negative 1/2.
2,
T to which power?
negative 2.
That's it. So this is t to negative 2. And now we are ready to differentiate. So let's differentiate. We know already the result for this. What should I write for 1 over t? 1 over t prime. We just determined the formula. 1 over t prime is?
That's negative 1 over t squared.
That's it. Perfect. So then I have negative 1 over t squared. And this one, I will apply the power rule. How do I write the derivative of t to negative 2?
That's negative 2t
Yes. To which power?
to the negative 1.
We have to subtract 1 from negative 2.
Negative 2. Sorry.
Yes. You can go back and rewrite it as negative 1 over t squared minus 2 over t to the third. Good. Now let's see what other problems we want to work on. Let's try. Anything else?